Today we're going to be talking about writing equations of lines and the steps to writing the equations of lines. First, find the slope. Second, pick a point that's on the line. Plug the point x and y in for x and y, and m in for m. Solve for b. And then write the final equation in y equals mx plus b, where you fill in m and you fill in what you've just found for b. So write the equation of the line through -1, -3, and 2, 1. So we first have to find our slope. So remember, that's rise over run. I'm going to do 1 minus a -3 to make it positive, and 2 minus a -1. I get 4 over 3. Now pick one of those points. First look and see, because I'm going to be plugging into y equals m I just found, x plus b. When you're plugging in an x and you have a fraction, what I would look and see is one of the fractions a multiple of 3 so that it cancels? 1 isn't a multiple of 3, 2 isn't a multiple of 3. Well, okay, so it doesn't really matter which one I plug in. I'm going to choose the one that's 2, 1, so 2 and 1. Just because they were both positive, I'm less likely to make a mistake, hopefully. So that's like 2 over 1 times 4/3. It's 8/3 plus b. Subtract 8/3. So this is 3 minus 8 over 3, which is -5/3. So then you write your final equation. Y equals 4/3 x minus 5/3. Okay, number two. Number two, write the equation of the perpendicular bisector of a line that passes through those 2 points. So the perpendicular bisector of that line. I'm going to draw us a picture just so you guys can visualize what this means. I don't need bottom quadrant, so I'm going to erase that actually. So 1, 2, 3, 4, 5, 1, and 1, 2, 3. So I have those points, and I want to find the equation of the perpendicular bisector. So it's a line that's perpendicular and passes through the midpoint. So perpendicular passes through the midpoint. So find the midpoint first. Remember, midpoint's average, so 5 plus a -3 over 2 and a 7 plus 1 over 2. That ends up being the point 14. Now find the slope. We're finding the slope of that line, of our segment. So the slope is, I'm going to do 7 minus 1, -3 minus 5, 6 over a -8, which is -3/4. So now, the slope of the line that we're trying to find, which is in red, I'm going to highlight it in green just because we can have more colors on our slide. When I highlight that in green, that's perpendicular. So we need to find our perpendicular slope to the segment that we just found. So that's going to be a +4/3. So now what we have is we have our slope, we have our points. The equation goes through the point 14 and has a slope of 4/3. So I plug in 4 for y, 4/3, and 1 for x. Solve for b. 12/3 is equal to 4. So that's going to be 8/3. So y equals m, the new slope, our perpendicular slope, x plus 8/3. All right, next question. Write the equation of a line that passes through the origin and makes a 135-degree angle measured counterclockwise from the positive x-axis. Woo, a lot going on there. So passes through the origin, so we know b is going to be 0. So if I make 135 measured counterclockwise, so I rotate it that way 135 degrees, I'm looking for the equation of that line. So I need to find the slope of that. This angle here is 45. 180 minus 35. When we're looking at a 45, 45, 90 triangle, if I draw a right triangle in there, because I need to find the slope from the origin to some point xy, I go the same amount. I go -1, up 1. So our slope of that line is -1. So our slope, -1, y equals negative x. Next example. Write the equation of a line tangent to that circle and passes through the point 7, -4. So first thing you want to do is check and make sure, I think the question's a little unclear, check and make sure that this point is actually on the circle. So if I plug in the point, 7, 16 plus 9. Okay, so that's on our line, that's on our circle. Let's draw again another picture of what we have just to help you guys visualize what we're doing. The center of our circle is 3, -1. Radius is 5. So, and tangent at 7, -4. I'm going to approximate it because my circle isn't perfect, just to give us an idea. So I'm writing the equation of that red line. Now, let's think about this. What do we know about radii and tangents? Radii are perpendicular at the point of tangency. So if I find the slope of this green line from 3, -1 to the point of 7, -4, I'm going to have the slope. So I'm going to find that slope first. So I'm going to find the slope, which is, I'm going to do -1 plus a -4. And I start with -1, so I have to do 3 minus 7. So I have a 3 on the top, a -4 on the bottom. So our perpendicular slope, or actually let me put that in red because that's going to be the line that we're trying to find, is 4/3. It just so happened both examples I picked, our perpendicular slope is 4/3. It's not always going to be that way. So now we can write the equation of the line. Okay, y equals m is 4/3 x plus b. Now what is x and y? That's why I drew the picture. What point are they going through? They're going through the point of 7, -4. So plug that in. 7 for x, -4 for y. So I have -4 equals 28/3 plus b. When I subtract, b ends up being -40/3. So then I need to write the equation. Y equals m 4/3 x minus 40 over 3. There are your lesson questions for the day. Please make sure those are submitted on time.